When you're working through the order of operations, or working through an expression, it's really handy to be able to recognize certain patterns that allow you to work on things simultaneously. I just got done explaining why when you're writing these out, you need to write the entire line out. But if you have as many operations as are going on here, it's going to take a bunch of individual lines. So it's nice to be able to notice when you can do multiple steps at the same time. And first off, I'm going to point out here, if we have parentheses there, times, and then parentheses here, this would be one situation where we can work on the insides of both of these parentheses simultaneously, because nothing that's happening on the inside of these parentheses is going to impact the result of any of the things that happen on those parentheses. Essentially, we're going to get some number out of these parentheses, we're going to get some other number out of those parentheses, and until I know what they are, they can't impact one another. So what I can do is I can essentially just kind of put on my my blinders and just look at the inside of these parentheses, this parentheses, and say, okay, well, I have multiplication and subtraction. I'll do the multiplication first. So I have 18 minus 4 in there. On these parentheses, I have an exponent and addition, so I can go ahead and do the exponent first. So this is 9 plus 1. Now you'll notice I still kept the parentheses and I still kept the multiplication on the outside of the parentheses. But I was able to do this one and this one simultaneously, kind of in the same step. Now I'll go ahead and do this again. I again have parentheses and parentheses, so I can do 14. This one, 18 minus 4 is 14. 9 plus 1 is 10. And so then, now I've done all the operations on the inside of the parentheses, I can go ahead and do the 14 times 10, which is 140. So the pattern that's really happening here, the thing that's important, is that whenever we have a higher priority operation and a higher priority operation, so two kind of islands of higher priority operations separated by a lower priority operation. So we actually see that same sort of pattern here. If we have multiplication and multiplication separated by addition, both multiplications are higher priority than the addition. They come before the addition. So this number is going to be completely resolved, and this number is going to be completely resolved before we can do that addition, which means I can go ahead and work on this group and that group at the same time, or in the same step. So 2 times 3 is 6, negative 4 times 5 is negative 20, and I'm just adding the two of those things. So negative 6 plus 20, well, I'm adding a positive and a negative number, so I'll do 20 minus 6, which is 14, but of course it needs to be negative because the 20 was negative. We end up seeing the same sort of pattern when we're dealing with division bars, because when we have a division bar, so something like this, 1 plus 2 over 4 plus 2, you can think of this as having parentheses around the top and parentheses around the bottom with division between them. So you could actually rewrite this as 1 plus 2 divided by 4 plus 2. If you're typing this into the calculator, that's how you would write it in the calculator. At least in my calculator, that's how you'd have to write it, because it doesn't write things as fractions. But in doing this, you can see we can do the 1 plus 2, which is 3. We could do the 4 plus 2, which is 6. And then we're looking at the fraction 3 over 6, which we can reduce. Alright, so let's do a couple of examples. I guess this one's not really an example of that. It's more just an example of the division bar. But you can see that this division here is going to have to take place after all of this stuff takes place. So that means I'll do, 2 to the 8th is, I'll ask my calculator. 2 to the 8th, looks like it's 256. So we end up with 1 over 256 minus 1, and that's equal to 1 over 255. And if I tried typing 1 divided by 255 into my calculator, it would give me a weird decimal, so I'm just going to leave it in fractional form. You can see 1 divided by 255 gives me 0.003921 whatever. 1 over 255 is a lot easier to deal with, and so it's also more accurate. So it's just a better version of the number. Alright, looking at this next fraction, 3 squared plus 4, I have, again, a division bar here, so I can work on the top part of the fraction and the bottom part in the same step. So in this first step, I will be looking at the exponent and the addition here, so I'll do the exponent first. I have subtraction and multiplication here. The multiplication needs to come first. So we get 9 plus 4 over 5 minus 6. Now I can again do the top and the bottom before I do the division here. I need to do the top and the bottom before I do the division. So I end up with, what, 13. And on the bottom I end up with, well, negative 1. 5 minus 6, 5 plus negative 6 is negative 1. And 13 divided by negative 1 is negative 13. Now, one thing I do want to point out, when we're dealing with these, you've already seen that if we have something like 2 times 3 over 3 times 5, I've shown that we can cancel. We can reduce these fractions. We can do that, canceling the 3 and the 3 here, giving us 2 over 5. This works with multiplication when it's on the top and the bottom. Note that this would not work if we had 1 plus 4 over 1 plus 5. We would not be able to cancel out the 1's here, for instance, because this is not multiplication. This would end up where we'd have to do 1 plus 4 is 5, 1 plus 5 is 6, and you can see this is actually 5 over 6. I can't reduce that number, and that's clearly not equal to 4 over 5. I say clearly because if you plug these into the calculator, we get two entirely different numbers. We get 0.83 repeating versus 0.8. So they are two different numbers. They're not equal to each other, so we wouldn't want to say that we could cancel in that way.